Now let's talk about non-blocking read repair. We've already seen what a blocking read repair is, right? So if you are assuming consistency level as quorum, you know the data is read from one node and the digest comes back from the other. And what basically happens is if the data and digest does not match, then you can go, figure based on the full data read what the difference is, and then based on that you patch up the node. All of this works well if your consistency level is greater than 1. But what happens if your consistency level is equal to 1? You're going to read only from one node. And because you're reading from only one node, you really do not have any other reference. There is no other data that you can compare the data that you've just read from. So what Cassandra offers is what is called as a read repair chance. Right, and there are two flavors of this: read repair chance and DC local read repair chance. Now, historically what has happened is both of them were configurable. And by the way, these read repair chances you can set at a table level, and I will explain what exactly this chance does. But in 4.0, the DC local read repair chance will be deprecated and removed. So you're going to have only one value, which is read repair chance. And there is a good chance it will default to repairing the replicas in the existing data center, which logically makes sense. If my application is in a given data center, I would rather have the data which is good and consistent in that data center and not another data center which can be thousands of miles away. So what does this chance do? So when at consistency level 1, we already saw there's nothing to compare with. So what happens is every once in a while, and I will quantify what once in a while is, every once in a while, after the coordinator has served the data to the client, it can turn around and do a data patching asynchronously, not blocking the read. And therefore, this form of repair is called as non-blocking read repair. So what does it do? Repair work is fairly straightforward. It's exactly the same as blocking read repair. So get the data from multiple, compare the timestamps, figure out which one is stale, and update the data. So the process is fairly straightforward. But the question is, when does it trigger? So read repair chance is represented in the form of a percent. And the default value, let's say, is 10%, which means 1 in every 10 requests, there is a chance, there is a possibility that the coordinator can turn around and patch the data across all the live replica nodes. And this happens asynchronously, naturally. Can you set this chance to 100%? Yes, you could. In that case, what will happen? Every single consistency level 1 read will force the coordinator to go check the data across all the live replica nodes and then patch up the data. That's going to only increase the load on Cassandra. The whole idea of operating at consistency level 1 was to reduce the workload on Cassandra. To say that, look, you read from only one, get moving. Be blazing efficient, be fast. That attribute will be, that objective will be defeated. So you can say that here is another way. Like you saw, hinted handoff looks to patch the data. Blocking read repair looks to patch the data. This is yet another way which attempts to patch the data to ensure that, hey, at some point in time, right, I can go back and look at the data consistency across all the live replica nodes, and I can fix the data to make sure that they are all looking the same. So these are all the automatic ways in which Cassandra will look to fix the data inconsistencies. It will ensure that, at any point in time, if any application, any Cassandra driver tries to read at consistency level 1, the objective is to give it the latest data as much as possible. But if you really look at the version 4.0 feature, right, where you have transient replicas, right? In some sense, this read repair, the non-blocking read repair, seems to be happening asynchronously and only on demand. Only when there was a problem, right, it would have the data in the transient replica and then it's going to push it through. So it's like kind of a combination of hinted handoff and read repair put together and asynchronous. So that's, I think, what is basically giving a lot of, benefit to make sure that Cassandra is self-operating. These kind of capabilities is ensuring, hey, you know what, with the least amount of human intervention, can Cassandra ensure that the data consistency across multiple replica nodes is maintained?